Figured I'd bring my notes this time so I don't have to think of problems. Okay, you're given a 1.5 liter sample of a gas at a pressure of 1,650 millimeters mercury. And the question wants to know how many liters if the pressure changes to 0.466 ATM. So the first thing I do when I do these problems is change all the numbers so that I can use them. Like pressure has to be ATMs, temperature has to be Kelvin, volume has to be liters. So I just read through the problem, and anything that doesn't match up with that, I fix. So if we have 1.5 liters, can we use that? Yeah, we're good, because volume has to be liters. Now we have 1650 millimeters of mercury. Can we use that?
No, we want to use ATM.
No, we have to get it to ATMs. So as a side problem to the actual problem we're working on, you have to take the 1650 millimeters of mercury, change that to ATMs. Some people can just look at that and know what to do, but to practice, you should put the label on the bottom so that it cancels like we did last time. And we're trying to get to ATMs. And if you look at that cheat sheet, across the middle it has what everything equals what. It's also in your book, but the cheat sheet's right there for you. Anyone remember what 1 ATM equals how many millimeters of mercury? 760. So if there's a number in the top, you multiply. If there's a number in the bottom, you divide. So this is 1650 divided by 760. Should be 2.17. So some people can get this far, and then they think that's the answer. What does this answer tell us?
Tells us what the ATM is.
Yeah, what the pressure started. So I go right in my problem, which I guess would be hard to do on a computer, but if you write the problem down to work it out, cross it off, put the 2.17 ATM. Then I keep reading through the problem, make sure all my numbers are right. Yep, I have another number here, but it's already ATM, so we're good there. So now I can actually read the problem. If I have 1.5 liters, let me write this down. This is another tip that other students have told me helped them. Write what you're starting with and what you're ending with. We are starting with 1.5 liters, and we are starting with the 2.17 ATMs. We want to know how many liters we're ending with, so this is the part we're looking for. And we are ending with this 0.466 ATMs. So now we have three numbers to deal with. Well, which number are we going to start our problem with? Volume. When in doubt, start with volume. So I'm going to start my main problem now, finally, with 1.5 liters. Now, I have two ATMs. Before, in the parentheses that I did for stoichiometry, what would we normally have put on the bottom so that it would cancel? Liters. But do we want our liters to cancel? No, because that's what the question asks us to look for. But we have two ATMs. Well, if we put an ATM on the top and an ATM on the bottom, they cancel. So we're going to put the ATMs in the parentheses. One's on top, one's on bottom. So they cancel each other out. But now, which number goes where? Because before our labels would tell us what number went there. Now our labels are the same. That's where our handy dandy map comes in. So if we have two pressures, we're starting with 2.17, we're ending with 0.466. So is our pressure going up or down? It's going down. So pressure is going down. What law is this? Boyles, because we have pressure and we have volume. Temperature is not even mentioned at all. Pressure and volume, no temperature. So according to Boyles' law, pressure and volume are inversely proportionate, or they do the opposite. So if our pressure is going down, what should our volume do? Go up. Bigger number follows the second arrow. So if our pressure is going down, our volume should go up, so our bigger number goes up on the top. This arrow is pointing up, so our bigger number goes up. Which number is bigger today? It's 2.17. Smaller one, 0.466. Now what I like about Boyles Law and Charles' Law and Guy-Lussick's Law is you can check to see if you're right. According to Boyles' Law, they do the opposite. Our pressure is going down, volume should go up. So our volume number here that we end with, should it be bigger or smaller than 1.5? Bigger, because we said the volume is going to increase. So if our answer is smaller than this, you done screwed something up. So you do 1.5, then what do I do with these numbers? By what? Okay, you're right, I guess. But how do I say it? If there's a number in the top, you multiply. If there's a number in the bottom, you divide. So I would do 1.5 times 2.17 divided by 0.466. And what do you get? I didn't write that part down. What?
4.66.
No way. Don't believe it. Look, I have a calculator right here. I'm going to check you. Oh, you're right. Okay, but what's my label going to be? Liters, because the ATM's canceled out. The only thing that didn't was liters, which is really good because the question says how many liters. So were we right? Did our volume go up?